Well, it says I'm live. I don't know if I believe it or not. Mic check out there. Anybody hear me? Oops, heard the telephone go off, so maybe it's working. I don't know. Looks like it is.
Good evening, Blue and Hunter.
Well, hello, Alan. Hello, B. How are you? Well, you guys didn't hear that because I had Discord muted. Good evening, fellows. How are you?
I'm not too bad.
Good, but I'm working, so I can't talk much. But Blue, you did enjoy that horizon statement that I posted earlier, huh? You can't see the horizon because it would be behind the curve.
Yeah. Well, the curve's blocking the horizon, obviously. You can't see it. That makes perfect sense. Yeah, it gets crazier by the day, doesn't it? Oh, my goodness. Yeah, I thought I'd do an impromptu stream this afternoon. Not a whole lot else going on. I think Jose's is not doing a show today. He's been kind of erratic here lately, but I think he's had some other work going on. But what the heck? We can get together and talk about stuff, huh? Heck yeah. Forgot what I titled this thing. Something about things that prove the Earth is not flat or something like that.
Oh, what you mean that bit about the surface we live on having a generally not flat overall shape?
Yeah, not like a pizza. Nope, not like that at all.
Yeah, not like a pizza is good because I mean, pizzas have topography as well, don't they?
Yeah, right. Yeah,
well, I'm pretty sure I tripped over a pepperoni the other day. Just saying.
Yeah, before all the scientists jump on me out there. Because it is true. The absolute truth is science does not prove things. But I'll tell you what, measurements prove stuff. And we've got all kinds of measurements that show us that this Earth we live on cannot possibly be flat. And it is driving people crazy. So any of you guys that want to join in the Discord chat, feel free. If you're not a member of the server, well, let's just see if I can post a link out there. Probably so.
And for anybody who does come and join us, if they make a post on the server, I will ensure that they get the permissions they will require to join us.
Right. There you go.
I shall be keeping an eye out.
As Alan always does, and I thank you for doing that, sir.
Oh, that's okay. I just thought it helps if they post because that way I can see they've joined.
Yep. Yeah, because unfortunately we don't get automatic notifications that somebody joined the server, or at least I don't. Maybe you know how to turn them on, but I don't.
No, and we choose not to give out automatic permissions because we've had problems in the past.
Yeah, that's true. Hello, Carl.
Oh,
Hello.
How are you today?
Pretty good. Had a long day, but I'm good.
Ah, excellent.
Just popping in and listen to you guys. Rounding off the day a little bit. Nice.
Yeah, we're just going to have an impromptu, calm conversation, hopefully.
Yeah, true.
Thought it might be fun. And we can talk about a few things. The guy that may or may not have a surveying certificate from that other channel has been pretty upset with me ever since the reciprocal zenith angles came out. Hello, Professor Phil Bell out in the chat. Sean Hawkins is out there. Man L. Queen in 1977. Petey, Real Cygnus, Gadget Inspector. A squirrel. I don't know who a squirrel. Who's a squirrel?
Good.
RH.
Sorry, Blue. I was just going to say, can I point out Chris Durham in the in side chat? Can we at least agree that pizza is yummy?
Yes, we can.
Fine, that's good.
Yeah, I have no problem with that. Well, most pizza is yummy. I've had a few that aren't all that good, but
In general.
yeah. Thor KC's out there. Doc C. A lot of people. That's good. Hey, Stingray.
Very.
How are you today? Or for you, how is the evening going, sir?
I'm actually feeling quite sick from something that I think I ate, but I've had a bug for a week anyway, so I ain't actually feeling too good at the moment, if I'm being honest.
Well, it's that time of the year.
Well, my young daughter went to nursery for 2 weeks and then came back with a horrible chest infection and a cough. Gave it to both me and my girlfriend. I was sick for an entire weekend, and I haven't been right since for the past week and a half. So
How old is she now?
she is coming up. Well, she's 10.7 months.
Okay, yeah, that's at that age they will get the runny noses and the chest infections and stuff. Whoops. Let's see, we got to do something about this bot out here. Hide it.
Hiding.
There we go. Hidden. Maybe that'll keep it away for a while. I wonder how that thing does that.
Well, it's a bot, isn't it? So, you
Yeah.
know.
It seems to find lots of channels. You see that same one pop up all over the place.
Oh, yeah.
They must change it just enough. We hide it, you know, and then it comes back. Yeah, but so yeah, the little one's feeling any better, Stingray?
Not
Well, it's hard to
particularly.
tell.
She's getting a higher temperature at the moment as well, so that we're monitoring that. But I think it's just gonna have to run its course. Most children around this area at the moment, including obviously by nature of it, their parents as well, all have this same cough, chest infection, cold type thing. So we're just all learning to deal with it.
Yeah, you'll find out that that's going to hold true for the next dozen years or more. Well, actually, quite a bit longer than that. It was always amazing to me that how we could make it all the way through the summer months when the kids were not in school and nobody got sick and everybody was fine. And within 2 weeks of going back to school, everybody's sick.
And that's just perpetual, is it? That's what I've got to look forward to.
Yeah, that's what's going to happen. Exactly.
Yes,
Awesome.
before you leave school, mate, and maybe even longer than that.
Well, apparently the little devils get together and swap spit with each other or something. And next thing you know, they're all sick and they make all their parents sick because we swap spit with them too, you know.
Yeah.
It's just the way it works.
Yeah, and it's amazing that you know, a virus that will give a young child just just make them slightly unwell will almost kill an adult.
Oh yeah, that's a fact. They'll be
I think-
walking around running 103 fever and act like nothing's wrong.
Yeah, no, that's the key. Ripley, my little girl, she does that now because she doesn't know that she's ill.
Yeah.
She just doesn't know, so she doesn't comprehend, so she doesn't accept it. So everything's just the way it was if she weren't ill. So there you go.
Oh yeah. Yeah, if you had 103 or, you know, the kind of temperature she's running probably at the moment, you would be flat of your back or thinking about going to the hospital maybe.
I don't know about that, Blue. My son walked into an urgent care with 103.
Oh
They
yeah.
just they put him in seating until one of the nurses noticed he stumbled a bit. He said he went from having one nurse taking his temperature to having 7 people around him getting double bagged with cold saline.
Yeah, I mean, her temperature at the moment is only, well, it's under 38, so she's fine. It's just slightly a few degrees elevated to what it is normally. She ain't got a fever quite yet.
He
Oh
said
yeah.
that he said that cold saline really hurts when it goes in when your temperature's 103.
I can't imagine it would feel good.
Well, you got to get your temperature down.
Yeah, they'll pack them in ice or rub them down with alcohol and do all kinds of things.
Yeah, they said that was next. They were going to put the sheet over him, pour water over him, and turn the fans on.
Yeah. That'll bring it down.
Yeah, the cold saline did it. He said the only problem with being double bagged with cold saline is you have to they're putting so much water in you that you have to take it out of you. And the
Yeah.
problem is that both of them are in your elbows, so you can't aim, shall we say.
Uh-huh. Hey, shout out to Man L for 2 pounds. Says the sun path for every hemisphere destroy flurfs. You know, so much stuff just destroys flurfs, it's not even funny. I'm trying to think what doesn't destroy those idiots. They're just not bright enough to realize it.
And then in the northern hemisphere, they have a bad explanation for how the sun moves. It just doesn't work in the southern hemisphere.
That is a fact. Well, the latest thing I've been harping on, and let's see if I can, you guys probably can't see that graphic, but are these reciprocal zenith angle measurements. Now, the guy who may or may not have a surveying certificate maintains he's got all these geometric proofs of things. Now, this is straight out of geometry, buddy. Nothing but. There is no way to verticals. You can call them zeniths, you can call them verticals, you can call them plumb. I don't care what you call it. All the same thing. There's no way the angle between the two of those and a line between them can exceed 180 degrees if they are parallel with each other. That would be Euclid Book 1, Proposition 29 or something. Whatever.
I've got a confession to make. Speaking of geometry,
What's that?
my The thing that I'm proud of in my Blender file, the Sun and Terminator line predictions, just based on the size and distance of things using no maths. I found an error with it. Or more importantly, I phoned Rumpus one day and then came to the conclusion that I know where the error is. I couldn't understand why some of the predictions were out. And it's because there was an error in the material that I use that I never thought to look for. And that's my sphere is obviously the correct size of the planet of the Earth, my distances, all that kind of stuff. Now, what I normally do when someone says where they are at is based off my geographical awareness, I eyeball place the observer where I kind of know their location is, albeit, with like, let's say, half a degree accuracy. And I always used to get it right. So, like Perth, Sydney, places like that. What I never thought of is that the texture mapped to that sphere was actually wrong and didn't have a dividing line at Greenwich, but rather was 1.6 degrees offset. So it's been wrong for quite some time by 1.6 degrees. I managed to correct it yesterday, so all good. Everything matches time and date now.
Yeah.
Yeah, the 1.6 is what GPS runs off of or something. I read something where they're slightly different.
But I just never thought that the map that the large terrain and continent map that I downloaded wouldn't have the dividing line between the left and right hand side of it at 0 degrees. I never thought that would be the case. It didn't even enter my mind.
So the prime meridian is offset.
Yes. By one, I think it was 1.7 odd degrees, but yes, which meant when I eyeballed and moved something to Perth, was a different result to when I set the lat long of Perth, and it was, over 1.6 degrees off the coast. So yeah, I fixed the texture basically. It all works fine now, and I'm very confident. I don't have to say it's 2 degree accurate anymore. I can say it's half a degree accurate.
Yeah, good.
But look on the bright side. It's still 1,000% better than anything any Flurf has ever done, even with the error.
Yeah, absolutely.
Yeah, pretty much.
They can't get anything to work.
I love how they say that celestial navigation only works on the flat Earth, and MC2's been out there for over a year with the simple 3-star fix that nobody can do.
Nothing about their methodology works. They don't have one to begin with.
I do think you guys should hold them to task more though in asking how and why, because they seem so intent that they know things. So as I was on Gem's server earlier listening to Jin CVR, and just by simply changing global to ground and calling it ground positioning system, it somehow think that's a win without being able to explain like a simple thing like, great, how does that work in the Grand Canyon?
Well, how come you need the Doppler shifts? You know that if the positions were fixed the way they say they were, they wouldn't work. You wouldn't be able to get. I read this somewhere why it needs to move and it's important, but
Or why during a static survey you need to wait for constellation changes. You have to wait for all this constellation to change during and log data the entire time. How does that work if it's coming from towers?
Well, that's
I
what it
think
is.
the way that they validate evidence is, if this were true, whatever it is that they're saying, does it support flat Earth? Therefore, great.
Good point too. You can sit there and, at least on some of them, you can sit there and watch the satellites come and go. Why would that work if they're not moving?
Yeah, a lot of people track them with telescopes.
With what?
The exact satellite that your receiver is looking at. You can see it.
You could track them with a pot from your kitchen. All you need is a GPS receiver. You need to turn on the GPGSV string that actually shows the signal strength for each one of your satellites. And you put up a pot in the air about 6 feet from your antenna and just move it around until the signal strength for one of the satellites drops out, loses lock. Now you know between that antenna and that pot, if you draw a line, that's where that satellite is. You keep it there for a little while, that satellite will come back into view. You can move the pot a little bit and it'll block it out of view. And you can actually track it across the sky just by moving that pot.
Cool. I never thought to do that. How big
I
a pot
don't
do you need?
doubt it.
Some of this like a fry pan would work.
Yeah, you can in the
Yeah,
field.
a frying pan.
In the field with a good receiver, it'll report the azimuth and altitude of all the satellites that it's receiving, and if there's like a water tank, not too far away, you'll see, oh, number 6 gone and back as it goes behind the water tank. It happens. Yeah, that's a frequent thing, because back in the day, particularly when there were less opportunities with GPS signal, you go out there and do a site survey to make sure that you're not getting masked by a balloon, or by a building, or like you said, something like a water tank. You can just watch them come and go.
Situation where I could actually count the support structures on a crane, all of the cross members on the crane, as the satellite would come in and into lock and then lose lock as it was passing behind each one of the cross members on the crane.
Yeah, I don't know why there's a question about where the satellites are or what they are. How can there be a question? You can track the damn things. Balloons can't do that.
Oh, and then you got the Doppler shift, which is too high for any balloon, and watch the Doppler shift go from a large positive value to near zero, then back out to a large negative number. Yeah, it's too easy.
Yep.
And the Doppler shift is one of the fundamental measurements. That's like your first order, ranging.
Absolutely.
Well, Blue, there has to be a question, because if satellites are real, then the Earth isn't flat.
Yeah, that does cause them a problem, doesn't it? Yeah, they kind of need they need the satellites not to exist. They badly need that, but they need so many
Yeah.
things. That's just one thing.
They need everything in the sky to be fake.
Yeah.
So don't even look at the sky.
Right. Right.
Yeah,
Could-
not
could
just
I-
unknown. Yeah, not just unknown, but fake. Oh, you don't know anything. You don't know what that is. You don't know what it's doing. I don't care. I'm just, why would I look at the sky to use, to measure what's at my feet? And then when you do that, oh no, now we're using sextants to look at the sky. Okay, we'll do that too. Oh no, now we got a sunrise, sunset. Trust your senses. It's not really setting, although it looks like it's setting. So don't trust your senses there.
Could I quickly ask Bill Hunter, Could you just remind me how many satellites in the American GPS constellation?
32.
In that case, my system must be seeing more than just the GPS ones then.
Oh, absolutely. If it's less than 5 or 10 years old, yeah, it'll be GLONASS, Galileo. Sure.
Yeah, most of them are considered GNSS receivers, which receives all of this,
Yeah.
most of the positioning networks.
Yeah, I just quickly flicked it up on my phone, and it's showing 23 out of 33 satellites at the minute. So
Yeah, most of the phone apps you can toggle GPS only or Galileo only, or they'll
Well, maybe
if
that's
you get
flat
a
Earth
listing,
proof.
and if you get a listing, it'll have an identifier whether or not it's GLONASS or GPS.
yeah. Well, this is just the one in my phone, so it's nothing fancy.
Well, sometimes there's
And
a
Alan, you
setting.
might have found the best flat Earth proof. If you could see 23 out of the 32 satellites, the Earth has to be flat, because if it was a globe, you wouldn't be able to see them all.
Yeah, but it says it's flicking between the total number of I think it's the total number of satellites it can see versus the number it's using for the lock. But yeah, it's
What it
hitting
does, it usually uses some a lesser number for the actual position calculation, because it only calculates its position using the ones that it has correctors for. So usually throwing in some satellites that are not corrected, you have no corrections for, it will actually degrade your accuracy to some extent, depending on how they run their algorithms.
And there are settings in many receivers to ignore the ones below, say, 10 degrees or 15 degrees. So it only uses the ones at the higher elevation angles to reduce ionospheric delays. Otherwise, it just gets noisy.
Some of the flat earthers say that GPS is affected by refraction. I'm sure that's happened, but how much of an effect would refraction have on a GPS signal?
A lot.
Yes,
If
a
you're,
lot.
and
That's what the correctors are for.
And that's why a good receiver uses dual frequency, because then it can map that refraction. And the refraction is an elongation of the signal, which is it could be several cycles longer than the straight line path. And then you have ionospheric propagation delay, which could cause the signal frequency to also be affected. So in the dual frequency, since each frequency has its own propagation characteristic, it can compare the characteristics against each other and calculate the total effect of the ionospheric delay.
I was just curious because it's something that a lot of them, well, one flat earther in particular brings it up as if some sort of killer for GPS. But okay, it's good to know that. It's good to hear someone who actually knows what they're talking about.
Well, yeah.
Like I didn't know there was much of an effect when it came to refraction.
Well, it depends. You say much. Now, much is a very subjective number. So if you have a single frequency handheld Garmin, it's going to give you a really good position, unless 3 meters is not good.
Yeah, that's the issue. Without that correction, how far off are you? And he
Yeah.
answers
Yeah, without
like you
yeah,
say.
if you're on a
a few
super
meters.
tanker and you got the receiver on one end of the super tanker, the errors are less than the length of the tanker. Then what do you care?
Exactly.
So we're talking about like a few meters as opposed to like a few 100 meters or maybe a mile.
Yeah, right.
Right. Yeah. Mile
Okay.
errors in GPS. You'd be talking like 1987 with a 5-channel single frequency receiver that that had many computer boards all stuffed into it. The thing is, receivers have gotten so much smarter, and all the software that they're pumping into it in ionospheric mapping and just computational speed and horsepower.
Early on, the biggest error was actually created by the government. It was the selective availability that actually dithered the time clock in the satellites.
Right.
That
Right.
actually was the biggest error, and that usually produce about 100-meter error.
Right.
Without the selective availability, you were getting about a 10-meter accuracy.
Right. They turned that off during the Gulf War because they didn't have enough units, and then never turned it back on.
Yeah.
Well, and civilian application got to be so prevalent, and transportation are using it, and emergency response vehicles are using it, and everybody and their brother is using it. So yeah, it's called SA, selective availability, and the designator for how good your little handheld receiver would work is called SPS, Standard Positioning Service. So yeah, it was set to be about a 100-meter radius, and then they lifted that, but they could re-invoke it at any time.
No, supposedly
they won't.
Supposedly they can't.
No, it's a switch.
Yeah, supposedly
it wouldn't do any
can't.
good now anyway. It wouldn't do any good now anyway because even during selective availability, most commercial applications were sub-meter accuracy already because we had correction signals for it.
Right. Right.
We
The
developed a
airports
way
did
of
that.
correcting for basically it was differential
Right.
GPS was
Right. That's the ground-based system that the flat earthers mess up. Yeah, airports did that. They knew. Yeah, you survey yourself a
right.
position, and you know where that position is, so you can correct for the SA.
Now
called the
anywhere in
WAS. That was called WAS, WAAS, Wide Area Augmentation.
the WAS is what they're using now. The differential GPS actually was a base station unit that was only good for a few miles around that base station. You'd set up a receiver on a base station. You would set up the position of that known position into the receiver. And what it would do is it would receive the signals from the satellites, and it would compare the pseudo ranges to each satellite to what it should be for that position at that time. And it sends a correction for that. And that was the pseudo range correctors it would broadcast, and you would use like a little data telemetry radio to your other receiver that you were maybe in somebody's backpack or on a boat or whatever. And that receiver would receive the same signals from the satellites, and it would put those correctors that the base station calculated into it and correct its position. And you were able to get sub-meter accuracy on it, even with selective availability on. The WAS signal, the WAS system actually uses dual frequency base stations scattered throughout the country that actually maps the ionospheric, it models the ionosphere based off of those dual frequency receivers and creates an ionospheric map. And then it also uses those base stations to do orbit and time correctors. And it sends those up separately through a satellite link down to your receiver. And it comes through another L-band channel on your receiver, and that actually breaks it out where it corrects it based off of where you are in the map. That was based off of a system that I used to work on many years ago that predated the WAS system. It was called SatLock. And it worked exactly the same way. The government actually spent a lot of money to reinvent the same thing we had been using for years. But Yeah, it actually works a little different than a differential GPS because it actually broadcast an ionospheric model. So it really didn't matter how far you were from the base station at that point. It was able to model the ionosphere based off of all those dual frequency receivers.
Yeah, there's different classes of corrections. You have RTCM, and then there was WAS and full phase correction. And John Chance, you would have a subscription system, and you put a separate receiver, and it would receive the corrections from its own series of satellites, and you had to pay for that. But as you said, that's so pointless now, because if you do that with if SA were reinvoked on GPS, but you're receiving Galileo and GLONASS, yeah, then it's just defeated.
If you were receiving WAS, it would be defeated. In fact, that was the Coast Guard beacon differential that everybody used for a really long time. It had a unique differential. It was a binary code that would actually come through very slow, but that came from towers. And that was developed because the rest of the military wouldn't give Coast Guard access to the P code receivers.
And that's the RTCM, which is Radio Technical Commission for Maritime Use. So, right, the Coast Guard had the RTCM, set up, and then airplanes started using it, then everybody started using it. And yeah, then you have phase corrections, not just pseudo corrections, for like on construction sites where you have your base receiver, and then you'll have, other receivers like out on the grader. They need much better than a couple of meters, because they're actually setting, grade for, earth movers. So again, there's different classes of correction. And that's why they call RTK real-time kinematic, as opposed to post-processed kinematic. There's 10 ways to skin that cat.
Yeah, the RTK, you could have RTK, standard RTK, you could have RTK OTF, where actually the receiver is actually moving. You could have moving base RTK, where it actually gives a relative kinematic direction between the two. And you could even have single frequency, standalone, single unit, single frequency RTK, where you actually set up a unit on a base, let it lock in, solve the ambiguities, and in that, then as long as you don't lose lock, your position will stay RTK accurate as you move around. That's very unusual to do, because if you lose lock, then you have to go set up right back on the base and wait for a couple hours to solve all the ambiguities again before you can go back and finish your survey.
Yeah. So again, with these different modes, you go back in time, and the more primitive ones, who seem really great, are now archaic. Yeah, OTF. Yeah, that is old school, on the fly.
Yeah, I was in for, I'm showing my age. The gray in my beard is it's there for a reason.
The system we used was called Starfire, and that was by a company called Navcom, which is a division of John Deere. Because John Deere, precision agriculture, they put a lot of firepower into it for getting crop dusters to be not 2 rows off when they're doing their spraying, or having autopilot in fertilizing machines.
Yeah, we worked for a long time to get John Deere to accept the Starfire receiver with the corrections. I was over there having meetings with Navcom quite a few times when they were in their Redondo Beach location. but yeah, they were wanting to use that as their drone system, and that's they were needing. I think they were striving for 10 centimeter accuracy at the time.
And that's the whole thing with when GPS was first introduced in the mid 80s, late 80s, they had no idea where it was going to go. They thought it would, civilian application they thought would have been minor because the equipment was really expensive, the software was tough. But then as electronics caught up and what went past them, now it's ubiquitous. You put a GPS receiver on your UPS package. You can buy a GPS receiver for $25. It does a lot. That same receiver, not very long ago, would have cost $5,000. And you go further back than that, today's $25 receiver would have been like top secret back in 1985.
I'd think that some of the GPS receivers we have today would have been completely and utterly unimaginable in 1985.
Yeah, without a doubt. Without a doubt. It went farther, faster than the military thought. And it's the greatest free lunch. It is one of the best returns on investment that has been laid out there as an infrastructure that has absolutely no cost to the user except for a hardware investment.
Those damn NASA guys pissing our money away again.
Oh, it's military, baby. Military, not even NASA.
Yeah, I know.
The crazy thing is we had already developed, or actually a buddy of mine actually worked on the project that actually had the development of the correction for GPS before GPS actually went online. Back in '85, they had developed the Starfix system, which used geostationary satellites to do positioning in the Gulf of Mexico. And they were needing ways of calibrating that system. And they actually, whenever GPS was coming online, for several years, they would actually turn it on for an hour a day. So they would use that time that the GPS was on to calibrate their system. Well, what they ended up doing was having to come up with a way to calibrate the GPS before they could calibrate theirs. And they were able to get their positionings way down to a really high degree of accuracy by using this corrected GPS to calibrate their system. So by the time GPS came online, they already had the corrections for it before it ever came to be, and they had the hardware to do it.
Yeah, it's been amazing watching the development of that stuff. It was pretty basic when I got my first GPS NavCom system in my airplane. And it was the Mac Daddy at the moment, but I paid a lot of money for that damn thing. And it wasn't even a moving map, believe it or not. The thing emulated an old VOR receiver where you had a course deviation indicator. And it was, but it was spiffy, I got to tell you. I could go GPS direct anywhere I wanted to, right in the side of a damn mountain if you wasn't careful.
Come on, Blue, real GPSs don't have maps. That's just a mapping computer that has a GPS built into it.
Yeah. Yeah, I didn't need no stinking map. I know how to fly without that stuff.
I mean, the thing that really gets me is back in 1985, when GPS was just coming in, we in the Royal Air Force were still using pretty much all valve-based radar systems for our air defence of the United Kingdom. And now look at it.
The crazier thing is the things that actually drive the development on some of this. The first satellite-based positioning system, 24 hours available, was developed by a survey company for positioning rigs offshore and doing offshore survey work. The high-tech, top-of-the-line systems later on was developed by agriculture companies, or GPS companies striving to cater to agriculture. It wasn't even military that was developing some of the high-end stuff that the military ended up adopting later.
Well, it developed rapidly. I know that. Because in just a few years after I put that Garmin GNC 250 in my Mooney, in just a few years' time, you had stuff that was ILS capable and precision approach capable if you had the money. And you can't
Back
be
then, the computing power was so weak, was that we had a lot of receivers we had to upgrade for the Y2K bug because they didn't do the 4-digit date.
Yeah. Yep.
All my receivers still have a Y2K bug. It doesn't even bother me. The only thing that's wrong is the date. Everything else is just the same.
Yeah, that's all that happened. Just messed the date up, that's all. Boy, I remember all the doomsday crap that was going on, though. It was funny, wasn't it? A lot of people close to panic that night. And nothing happened.
Well, the thing about the Y2K, or the weak 2K bug, it occurred at 1,024 weeks because they hadn't anticipated a week number being in excess of 2 to the 8th. And yeah, it was a little bit harrowing because nobody knew, because that completely blindsided them. That was a major screw up at the design phase, because 1,024 weeks is like 25 years. They just didn't think that through. And so in the interface control document, they dedicated 2 to the 8th bits for the week number. Everybody thought that was cool because that was like having a computer with 1 gigabyte of memory. You'll never run out.
Yeah, that was an oversight, no doubt about it. But there were all kinds of predictions flying around about, collapse of global financial systems and all kinds of shit.
To be fair, they did have a lot of work done. They had a lot of work done to prevent it. We did have a few systems of ours that actually shut down, but luckily it was non-critical systems, but we had caught and upgraded all the other ones. It was like some systems that were on the shelf somewhere that we had forgot about. Go to use them later and they didn't work. But all the ones that we were using at the time, we had made sure we had got upgraded and everything.
Yeah.
But that's what happened with a lot of the other stuff. Some of the stuff would have worked just fine. They had a few things that may have shut down. It would have taken an upgrade, but luckily those upgrades were pretty readily available for most of the systems. Everybody worked pretty hard to get all of that done.
Well, GPS is still one of my favorite ways to think about measuring the curvature of the Earth, being that the curvature is so damn slight. It doesn't curve much in a mile or 2 miles. Not that much in 5 miles, really. But when you get out 15 or 20 or 25 miles, man, now you can really start to see it. But you need something to see it with.
Can you actually see it though, Blue, or do you just see the effects of it more if we're on about our eyes?
Well, you see the effect of it directly with GPS.
I don't think flat earthers will ever trust GPS.
Well, they don't. They don't mind using it to find their way to grandmother's house or.
No, don't get me
Yeah.
wrong. I'm not saying they're massive hypocrites. They are, but I don't think
Yeah.
they'll ever trust GPS for the shape of the planet. But they will use it to navigate to the shopping center.
Oh, heck yeah.
Yeah, Rakia has GPS, and he says, "Oh yeah, it's the best thing ever." And he's gone out over the horizon, can't see towers anymore.
Yeah, can't get a cell phone to work. Can't get any of that kind of stuff to cooperate. They can be 100 miles off the coast, and the GPS system is still telling him where he is. But he doesn't believe it.
No, don't forget, Blue. He just thinks that the land and these towers are still there within line of sight. It's just that you can't see them because of reasons.
Yeah, exactly.
Not
Exactly.
those damn reasons again.
Funny
In the
how it
early
never
90s,
changes.
we surveyed the middle of the Pacific where they had some of the smoker vents from the northern Pacific all the way down, and I think the survey ended in the Galapagos Islands, and used GPS the entire time. Seemed to work pretty doggone well, and that's literally thousands of miles from the nearest civilization.
Yeah, exactly. There is no place that doesn't work unless you mount the antenna on the underside of your airplane, in which case it won't work at all.
It doesn't work well in cities.
Not when you got
Not the high
buildings
end
all around
GPS.
it. Yeah.
Yeah. The
That's-
lower end consumer grade GPS is what they'll do is they'll open up the filters on the inputs to where they could receive multipath. So they'll receive signals that'll bounce off of buildings.
Right.
Well, they also use something called fuse location services, which use very
Right.
basic cell tower triangulation, but also, the Google Street View vehicle that's going around everywhere. That was also measuring very detailed signal strength of routers that could be identified with kind of the header packet and the identifier, so that they could pipe that into their location lookup service, so that when the fuse location services are enabled, it can use GPS cell tower and then the Wi-Fi signals from your home routers.
Yeah, I guess I was showing my age again. I was going back before Google was a thing.
I go back before Google was a thing as well.
I go way back before Google was a thing.
I was talking about the GPS signals in cities and stuff like that. Google wasn't a thing yet, and so if you got the cheap GPS or the consumer grade GPSs, it would work in the towns, but the high end survey grades would not.
Yeah, I
You
mean,
would
one of
be
the
lucky to get 3 satellites.
one of the first headline features, I think, of the iPhone second generation 2GS was that it had a GPS on it, assisted GPS, which was nothing to do with a satellite network. It was literally just receiving cell tower triangulations because they'd got a geographical map so that they can triangulate based off signal strengths, and it was accurate in some cases to 100 meters, in other cases to about 1 or 2 kilometers.
Yeah, I remember talking with a sales guy, and I said, "Look, I talked to somebody and said that if they don't have cell coverage, they don't get a position. This isn't real GPS." He said, "Oh no, it's real GPS." I said, "No, it can't be."
No, definitely not. I think it faked it because they had clever algorithms that would do accelerometer and direction tracking based off magnetometer and things, while on a good fix, and then approximately placing you where you were, then snapping you to where you probabilistically were, and then try and route you from that scenario forward. So it was a lot of fakery because it would go very wrong sometimes.
Yeah, they used a lot of dead reckoning.
Yeah.
Yeah, but like you said, it kind of snapped you to where you could be and refused where you couldn't be. So they had like outlines of buildings and stuff. Okay, he's not in the building, he must be in the street.
Right.
Yeah, I mean, it still does that now. Your GPS on the road as you're traveling might not get a very accurate fix, but because you're traveling at speed, hey, you're on the highway. So it might have got a rough approximate fix where you could be not on the highway, but no, you're on the highway.
Yeah, they were a little curious out in the chat, Hunter, about multipath. That's really simple.
Multipath
That's
is?
a simple thing to explain. That's the same signal bouncing off of something. This is a problem we used to have before there was such thing as cable television. We actually had a TV antenna. If there was a big water tower sitting around someplace, you wouldn't see one image on your TV screen. You'd see 2 of them. You'd see the shadow because it was bouncing, coming directly to you, but bouncing off of something else and coming to you. So that was quite irritating depending on where you happen to live. That's simply called multipath reception. Yeah, you get in the middle of a city somewhere, you get all kinds of paths. Hey, welcome to Baby. How you doing today, baby?
I'm good. How are you? How are you?
I'm doing pretty well.
What's the temperature like? It's suddenly got cold in London, and my boiler's broken down, as they do when it gets cold.
It's 44 Fahrenheit where I am, which would be about, I don't know, 6 or something.
10 degrees.
Yeah.
We do centigrade.
Yeah, so it's about 6, I think.
Oh, cold.
So yeah, chilly.
Yeah, we're 9 degrees centigrade. It's 50.
I've got a serious
So how's the
question.
show going on?
Oh, sorry.
How's the Sorry, go on.
I was going to say I'm going to go shortly, but I've just got a quick question for the room because I created. I'm rendering out a few animations of my planet with like this multi-layered shader on for clouds, atmospherics, and all that kind of stuff. And it's even got a nighttime side. But for the nighttime side, for the resolution that I'm rendering it, I had to create a lighting emissive map for city lights. And in order to kind of get the accuracy, and it's still not as accurate as I would want, I had to create a 42,000 by 28,000 pixel image. Now, normally a megapixel is obviously 1,000,000 pixels, but I'm at 1.3 billion pixels. What's after a megapixel?
I have no idea.
I don't either. But that's the resolution of the map that I'm using for my city lights.
Gigapixels and then terapixels. Come on.
Oh, yeah, there you go. Yeah, sorry. Yeah, that's it. Cheers, Al. Jesus. Right, yes, I'm at 1.7 gigapixel texture for the city lights. There you go.
Well, that should do it.
Oh, before you go, Stingray, I'm just wondering if I can get you to do me a favor. If I send you a video file, do you think you could try out a particular filter on it in DaVinci Resolve for me?
Well, I've got latest DaVinci Resolve Studio 18, so sure.
Because I want to find out if the anti-flicker filter will fix the flicker in some of my videos.
Is it
before I spring to the software?
Is it a light based? Is it a power grid based flicker, or what's the source of the flicker?
It's unfortunate variations in the exposure due to the fact that the camera keeps opening and closing the aperture every time it takes a frame of video, as it's taking a frame of video about once every 2 seconds.
Oh, see, I've never left automatic exposure compensation or anything like that on when doing video, so I've never had to solve that problem before. So yeah, sure, if you Dropbox it to me, I'll have a look.
The problem is that I'm using a still camera doing a time lapse, and it stops between frames. It opens the aperture up to maximum and then shuts it down. And I think it doesn't always quite hit it perfectly because it's not designed to work that way. Because the exposure doesn't need to be that accurate when you're not shooting video.
Yeah, I shall do my best for you, Al, if you want to send it.
Cheers, mate.
I see you've had some interesting conversations with the guy over on the other channel, baby.
Yeah, you mean the guy whose name begins with B?
Yeah, the guy who may or may not have a surveying certificate.
yeah. That was an interesting one. Yeah, there's a couple of good ones. There's the idea about what is the time of noon, and Paper Organist cleverly points out that if it is local noon, then it must be noon. So you don't need to know the time because it's noon. I was saying to get your longitude, you need to know the time of local noon. And Paper Organist says, no. You know, if it's local noon, you know the time because it's local noon. Yeah, right. I don't know if he's joking or whether he's serious.
He really is that dumb, I think.
You think he really is? I mean, it's an interesting question. If you tell the time by the sun, then local noon is noon, right?
Yeah.
That's it. You know the time.
Yeah, exactly.
You know the time. On the other hand, there are other ways of telling the time. I suppose I should have added that you have to know what your Greenwich Mean Time is. So you're out in the middle of the ocean somewhere, and you've got local noon. Okay, what is the time in Greenwich right now? But I thought he would have known that.
You would think. They are, they remain so confused. And I can't figure out whether it's real or.
It's very hard to tell. And then Bev's going on about this. You can tell fuck all with a single angle, with an angle.
You can tell your latitude with it.
Sorry?
You can tell what your latitude is with an angle, nothing else.
Yeah, I said that. You can tell your latitude, so you can tell something from an angle. And he said, "Oh well, the latitude is the angle." So, to say your latitude from the angle is just to say your latitude from your latitude, your angle from your angle. Yeah, because a latitude is a location. It's the distance you are north. If you're taking Polaris.
Yeah.
It's your distance from the equator. As we all know.
No, of course. That's what it gives you. That's what it returns. Why they have such a problem with that, I don't know.
Well, I think Bev knows exactly what he's doing.
I kind of believe that too.
Yeah, there's hundreds of years of sextant work. So, and you don't got to go back that far to when a cruise liner or freighter leaving California going to Hawaii got there entirely by sextant. There was no electronic nav aids, and they got to Hawaii safely, reliably, and not by luck. But that's not
right. And if you look at the old voyages like Cook found a bloody island in the middle of the Pacific, which is a huge bloody sea, isn't it? And an ocean. He went there and he found it. He found the latitude. He found its position. Then he went back to England. Then later he went back and found the exact same place. So how do they explain how someone like Cook or these other great explorers managed to find these places successfully?
Couldn't claim discovery of an island if you couldn't quote its location.
Yeah. Correct.
Yeah, and many of those things are just a few miles by a few miles. They're small, yet you can find them.
The latitude is good. They always get it right. But I've got some old maps where, if you look at the longitude for South America, say, they're always out by a couple of degrees because they can, as we know, they couldn't get the longitude. They had no timepiece that would give them that.
Yeah, that was the big mystery.
That was the big one.
What was the prize? It was something incredible for the time.
I have another nice map. From the 17th century where they didn't know there was a place in Antarctica, but there's a big hole saying sort of southern lands. So they had a big space for Antarctica. They knew the space was there. They just didn't know what was inside it for another 100 or so years. And they had it all totally figured out.
Oh yeah. Yeah, they weren't terribly detailed about what was south of the 60th parallel down there. But they knew it was there.
They knew there was something. They knew the space was there. They knew there was a southern pole.
Yeah.
The southern geographical pole. They just didn't, I think Cook went there and he saw ice. I think you can infer from the fact there's ice, there must be land, there must be glaciers. I think they saw birds. So they knew stuff was there, but it wasn't until, who was it? Ross. Actually, no, there was a guy before Ross, a Russian, Wellhausen.
Yeah, that area is remained a mystery until well up into the 20th century, really. But they love to misquote people like Admiral Byrd. Yeah.
Oh, yeah,
Nobody
the,
knew very much about the interior of Antarctica. Not much. That is a very inhospitable place to go.
Yeah, I had an argument with someone the other day who said, I said I'd been there, and they said, oh, well, if you tried to get out, and onto the mainland, someone would have stopped you. And I said, well, yeah, the crew would have stopped you for a start, and you die pretty quickly.
Yeah, I would think so. Even on a hot day, it's still cold.
It's still very cold. I did meet a woman who'd walked to the South Pole, though, Felicity Aston.
Really?
Yeah, she was. It wasn't the whole way. She was airlifted to where across the, well, which one is, there are two ice sheets. There's the Ross Shelf and the Ron, I think. She went on the Ross from McMurdo, and they airlifted her to the edge of the ice shelf where it meets the land, so she could officially say. Then she walked up the Everett Glacier on her own with skis, and walked across the plateau, the Antarctic plateau, which sounded really boring. I mean, it's just mile after mile of just the same scenery. I think she was saying she was going mad at one point, hearing things, seeing things.
Wow. That's an adventure.
That really was. And then she walked then she got to the Scott Amundsen station. They walked back to the Ron ice shelf. First woman to do it. I think first person to do it, to walk across Antarctica.
That's incredible. I can't imagine attempting a thing like that. But then again, I don't have a death wish. You almost need one if you're going to climb out there on that on that ice and talk about walking that distance. My God,
It's a hell of a long way.
I can hardly imagine Ranulph Fiennes doing the whole polar circumnavigation, essentially on foot.
Yeah, when you try to compare what it would take to go from the coast to the South Pole, I mean, yeah, it's like walking from New York to Chicago or New York to St. Louis.
Yeah, it's something like that, but it's much colder and not at all hospitable.
Yeah, but walking 1,000 miles and you only have your own supplies.
Yeah.
And they will let you die.
There's also a yacht race, isn't there? You can sail around Antarctica.
yeah.
Forgotten the name of it.
I think it's ongoing right now.
Is it? Oh. That'd be the right time, wouldn't it?
They do it like every 2 years or something.
And they're not allowed to use GPS. They must use sextant.
Is that right? They should take Bev then. and drop him off on some island somewhere.
Oh
Hey,
no, I
I'm going to
guess
sign off. I'm going to sign off now. I want to check out this. You heard this Article 5 thing with Poland.
yeah.
I heard about the incident. I hadn't heard anything about a NATO response.
Well, in theory, it triggers Article 5 if they can prove that it was a Russian missile, but it's on the news now. So I'm going to say good night, everyone, and see you all later.
Yeah, thanks for dropping by, baby. Good to talk to
No
you.
problem. Yeah, which button do I press?
One
hang
sec.
on.
Go on.
Yeah.
Red one.
Oh, here we are, Robon.
He's gone. Well, what else we got on our minds tonight?
I posted an image of my 1.3 gigapixel city lights map in use out of one of the frames of the animation.
Well, let me see. See if I can figure out how to show that. Oh, yeah, there we go. Let the folks out there in YouTube land see it.
Actually, I created the cloud texture as well, so which is the same size. So it's not. I've done 2 of those maps now.
Well done.
And just think, you only need to do the cloud map once every 10 minutes to keep up with Himawari.
Yeah, but I have to do it at least 29.97 times a second to keep up with the ISS live feed as well. So don't forget that, Al.
Yeah.
Just the Americans to use 29.97 as their as their grid frequency. What the hell are they doing?
No, they use 60 as their grid frequency. The reason why it's 29.97 and not 30 for the frame rate is because back in the days when it was CRTs, you had to allow for this thing called flyback.
Oh,
It takes time, even though you're not firing the electrons, it literally takes time to move the beam from where it is at the bottom of the last scan line back to the start of the top scan line.
all right. I'll let them off then, Al. Thank you. Jesus, they're all right again.
It's the same for PAL over here. It's not 25. It's not 25. It's 24 point something because of that technical bit of moving electrons around.
Yeah, that just hung on. I'm sure you can hear Joker barking up there.
Yeah.
Get him to shut up. Yeah, that's absolutely true. That it does take a moment to snatch that beam back up to the top left corner and start again.
So it's the scan line latency then.
Yeah, sort of.
Well, the reset latency, yeah. Wow.
Yeah.
You guys always had better television than we did.
Oh, here you go. I can add something to this conversation. Do you know the BBC? Obviously, I think it was the BBC that broadcast in colour for the first time, but they had to they couldn't disregard the black and white signal, which is where chrominance and luminance came from. But I think the BBC also developed or jointly developed I don't know whether you guys had it in the States, the SVHS cable. Did you have that?
I don't know.
It's like a little, so it had dual pin left and right, so 4 pins, and then a center kind of rubber guide, and then a ground ring surround, if I remember correctly.
I can't think of anything like that.
But what was good about that, and I don't know whether you know this, Al, is the chrominance and luminance signal that goes down there is duplicated and inverted on one side to mitigate interference on the cable lengths.
Yeah, that's a very it's a very standard practice to do that, and I forget what it's called now. My flipping brain's dropped out. Differential signaling.
Yeah, I like that.
Yes, it looks a bit like that's the one. Yeah, they would have had them in the US, but of course they would have been sending the North American TV standard instead of PAL or CCAM if you're French, because you know.
It's NTSC.
Is it NTSB? Because that's National Transportation Safety.
No, NTSC.
Ah, sorry. Yeah.
Yeah, that's video. Yeah.
Oh yeah, sorry, yeah, not SVHS, S video cable. That's what I'm on about. Super video.
Yeah. Right.
I've still got a SCART device somewhere. VHS tape player somewhere.
Yeah.
Oh my God, I've just realized my daughter not only will never know what a magnetic tape music tape is, or a compact disc, or probably even a Blu-ray disc. How mind-boggling is that?
Yes, you will, because her dad's going to have all that crap knocking around the house, isn't he?
Well, yeah, I got a lot in the loft, I won't lie.
Yeah. I'll bet you'll be telling her all about it.
Oh, I can tell her about the thrilling HD DVD war between Toshiba and Microsoft versus Sony and everybody else with Blu-ray. It'd be amazing.
Yeah. On discovering that pulse dialing still works in this modern day and age, I so want to get myself a proper rotary dial phone.
Do you know what I used to? Well, I suppose it's long enough. I suppose it's long enough now that I can admit to this. At school, we had one of the first. We had a DTMF tone phone that was installed in the phone booth, which was in the center of the school. And I had a little Scion personal computer which could generate DTMF tones, which meant I got to call anybody I wanted for free.
Yeah. Well, you used to be able to tap up and down on the on the two little nipples that hung the phone up to to Polestar if you got the cadence just right.
Oh, really?
But
Oh yeah, I did that all the time just for fun, and just to aggravate my mother mainly. She hated it. Always funny. But yeah, you didn't need the dial if you didn't want to use. Actually, it could be faster just clicking the switch. Yeah, that was back in the day when telephone exchanges were full of things called stepping relays. Weird gizmos.
oh yes,
Stepping switch. Yep. And that's what it was doing. It was counting how many times the contacts opened and closed. Each time it did, it would advance its armature.
Yeah, worked with a few of those.
And if you went in the telephone, found a way to get in the telephone exchange just to see what was going on in there. My God, there was a lot of racket. All those things going clickety clack. Crazy.
Well, I mean, for the radar system I worked on, all of the control logic was all done with not valves and not transistors, but post office relays.
Really?
Yeah, they literally built logic gates out of relays with with your logic signals being 0 volts for a 0 and minus 50 volts for a 1.
Well,
So
you can do
yeah,
that.
and because remember, it's driving an awful lot of coils.
Yeah.
So don't touch your logic. It bloody hurts.
I'm quite sure. Yeah, pain is a good teacher, I found out.
Yeah, I mean, we had one fault that I inherited off a day shift, and we finally cleared it about 4 a.m. And we'd been the waveguide systems had these big barrel switches, and of course they've got micro switches at the ends to tell it that it's moved. And although the switches were making contact and everything else, the system wasn't detecting one of these switches going into position. And then at 4 o'clock in the morning, I accidentally touched it. And the fault just went away. So of course you've got to put something on the job card, haven't you? Especially to account for like 10 hours worth of technician time. So it went down as minus 50 volts taken to earth via load, fault cleared.
Yeah, I'm sure that would get your attention. Not terrible, but
Yeah, I was lucky. I never stuck my fingers in anything that carried any serious current.
oh, I've been
Although,
whacked a few times. Not horrible, but enough to hurt.
yeah, I mean, high voltages with not too much current kind of sting, but they don't. Yeah, it's not going to be too.
I've got a question, and I know the answer. Well, I know the partial answer to this is it's a stupid idea and I shouldn't do it. But besides the obvious safety issues, if we move them to one side, when I was having my extension built and all the downstairs electrics rewired, the existing house circuitry on one side of the house was left intact, but I had a new consumer unit put in and it wasn't labeled. So obviously the fastest way for me to figure out what fuse is responsible for what part of the let's say the sockets or the lights or something like that, when I had access to the wires, is obviously just to
Tell me.
well, you know what it is. I don't
Yeah.
care about the screwdriver, but is
Oh,
there
my
anything inherently bad about doing that?
Yeah, actually, yes.
Yeah, but besides the safety
Yes.
thing, Blue, seriously.
Well, seriously, breakers have a finite lifetime. Okay, every time it has to interrupt a fault, you damage the contacts in there a little bit.
Right.
Now it'll do
Right,
it,
well,
hundreds of
in
times,
my
probably
wait a minute,
thousands of times. But
in my ignorant defense, not knowing that what you said to be a fact, I also had many I also had many fuses available to me to replace ones that went, and it saved me a shit ton of time. It really did.
oh yeah, yeah.
I only
Were the
lost one
actual
screwdriver.
were the actual fuses or breakers? What were you talking? What are we talking about?
Trip breakers.
Okay.
I've actually done that quite a few times. Not necessarily for that reason, but in trying to find a fault in a piece of equipment that was kept tripping the breaker that was feeding on that piece of equipment.
Yeah. Well, sometimes you get down to doing that just because it's expedient. But
yeah, well,
when a
yeah,
breaker
time is
opens
money,
up under
and
a fault, you are doing a little damage to the breaker itself. It'll do that
absolutely.
thousands of times for sure, but still, that's one less time it's going to do it.
But you end up with some arcing and some charring to the contacts because it's under full load when it opens.
Yep.
But doing that once or twice to fix a problem that got everything shut down, sometimes it's a little bit of a no-brainer at that point. You're
Oh,
shutting
sure.
everything down.
Yeah, I wouldn't recommend turning the lights off that way every day, but
No.
So I guess the wear and tear is true of actually manually flipping the breaker then as well, right?
actually it is.
Yeah, but to a lesser
Except
degree
that
because you're
except
not
that you're
at
not in
full
a fault
load.
condition.
Right.
Yeah.
Okay.
That's
If
the
your
difference.
breaker's rated for 15 amps or 20 amps or something, you're putting the full 20 amps or actually in excess
More
of
than
20
that.
amps on it when you do that short. Yeah.
Yeah.
Yeah. Most of mine are 32 amp, but I've only got like 2 8-amp runs for LED lighting.
Yeah. When you short it, you're getting a lot more amperage than that.
Yeah, well, you're
On
just
it to
limited
make it
by the
trip
resistance
quickly.
of the cable that's there.
Yeah.
And the rate of change of current has to do with the inductance of that. So you're gonna get substantially more than what the breaker is rated for, or what the breaker steady state rating is.
I'm over it now anyway. I completed expediting labeling all the breakers, and I don't have to do it again. So I think I'm safe now. Cheers.
There you go, Blue, in the live chat. The guide to fuse replacement.
Yeah, let me see. Oh yeah, got it. Yeah, I've used all of those. Let's show it to the YouTube. Let me get this up on the screen.
Yeah, I like the 350 amp audio visual auto alert.
Yeah, 2000 amp slow blow. Yeah. I've seen
Oh,
those.
just I think I asked you this, Blue, ages ago, and you answered me, and I've now got it working. By the way, just in case anybody's interested, I used standard Cat 5e, taking note of twisted pairs to bond them so that there's no disparity between the signal, but then using the network cable to distribute to use it as speaker wire for remote speakers,
Yeah.
and it works absolutely fantastic.
Oh yeah, it should. Now the audiophile, purist will be vomiting and rolling around on the floor when they hear what you just said. But
No.
to me, it really doesn't make that much difference. I'm real sure my ears are not sensitive enough.
There you go, Alan. That's the explanation of capacitors in the live chat.
Yeah, that one is also good. It definitely makes sense once you say that, doesn't it?
Yeah.
Well, and forgive the layman question. So the AC passes through the capacitor arcing at the same frequency of the current.
Mm-hmm.
Nice.
Yep. Actually does too. In DC, not so much. Yeah, that's kind of a clever drawing. I like that.
I can see it making it easy for somebody new to it to remember.
Yeah. Two pi FC or something like that.
Yeah, that sounds about right.
Somehow I was expecting the guide to fuse replacement to be penny, nickel, dime, and quarter.
Alan's from the UK.
Yeah, I've been to the US. I understand coins that that are different sizes and therefore will carry different amounts of current.
Yep.
You just call them different things to what we call ours. That's all.
And just FYI, AGC fuse for inside of a car, empty 22 casing, preferably an empty one, actually fits in there quite nicely.
Yeah. What in the hell is this, Alan? Explain that transistor with two emitters, okay?
Sorry, Blue.
Explain that transistor with two emitters. I'm having issues here.
Look, I saw it. It made me laugh. I thought you'd appreciate it.
Yeah, there's some silly stuff in there. Please stop tying the inputs of the OR gate to the output. Oh boy. Yeah, I'll have to have a good long look at that after a while.
I like the network of one ohm resistors.
Yeah, I was just about to say that I think I had that network of resistors where I had to calculate the value for each of them and the current through them for one of my tests one time when I was back in school.
Oh, I see that mess you're talking about. Oh, goodness.
Yeah, I want the current and the voltage drop across each one of those. Go.
Well, we can do it. I don't want to do it. We could do it.
I also like the timer in the top right corner.
Yeah, 666. That's the upgraded version of the 555, I guess.
Yeah.
That one came out of a Freemason factory.
Got holy water down there in the bottom right. Wow. Okay. Well, that was fun. Now what do we got? Ah, Timbo Turtle's out here. What the heck is that thing? Says I used to have an old fish tank heater like this one to change the temperature of the old one. You had to take the element out of the tube and turn a screw. I did this when I was about 15. I left it plugged into the wall, and while using my metal screwdriver, the thermostat kicked in. Oh boy. Threw me across the room. Yes. Well, I know the problem, Timbo. Happened to me when I decided to check the filament voltage on a 5U4B using an uninsulated alligator clip. That will ring your bell, buddy. Seems I forgot that was B+. I hear you snickering too, Alan. You know what I did.
Yeah. I mean, to be honest, the 5.3 volt AC heater circuit was the one supply that we were always really careful about not touching.
Yeah.
Because, the fuse, the fuse from the buzz bars was 120 amps.
Oh, yeah.
And it was more than capable of providing plenty enough current to blow those fuses. And of course, if you had to remove a unit out the rack, it was the one connector that you had to unscrew while the power was still connected.
Yeah, things can become exciting quickly.
I cut through a 240 volt I cut through a 240 volt mains cable with a pair of 10-inch tin snips once while it was still live as well. Not that unpleasant. spark was quite large, though. Well, I think I was lucky because I went, because of course I went through live, neutral, and Earth all at the same time. So mostly it just shorted out across the blade. Left a fairly decent divot in the blade. In fact, of course, the muscles in my arm all spasmed, so I ended up throwing the tin snips up in the air. And the worst bit was when the tin snips come back down and landed on me. I think they got about 5 or 6 feet in, needing the time.
Yeah, I'm just giving somebody a roll here. There we go.
Do either of y'all know what a megger is?
A megger? Absolutely.
Oh, yes.
Yeah.
500-volt megger will ring your bell too.
Not as much as hooking it across a 10,000-foot coax cable, letting that charge up, and then disconnecting your megger. It holds a lot more than what comes out at one point. And then kneel down on a wet steel deck of a boat and touch that.
No, I won't. Sorry.
Yeah, I'd like to say I won't either. But
I used to have a very nice wind-up megger that actually did 1,000 volts. You could you could really have some fun with that. And of course, oddly enough, for a piece of test equipment that's used so much across so much of the world, including the States, a British-made product.
Oh, all gone quiet, huh? Had to leave for a second. Well, what do you think, guys? I've kind of run out of stuff to talk about.
Yeah, I think we might have run out because we've been chatting for 3 hours nearly, haven't we?
No, about
Was
2.
it
Yeah, about 2 hours. But I got kind of a late start, so. I'll tell you what, we'll end it at this point. Say bye-bye to everybody out there in YouTube land. Thanks for joining us, folks. All great fun. And with that, we'll see you on the next one.